This lesson is Quadratic Inequalities in Two Variables, and it is section 9.3 McGraw-Hill-Ryerson, Pre-Calculus 11. At the end of this lesson, these are the things that we would expect you to be able to do. I encourage you to interact with the video, to pause, do the questions, rewind to get information. When you press play, I'll be giving you the solutions to everything. This particular lesson focuses on outcome RF7. And you need to be able to draw a parabola, so graphing a quadratic function, chapter 3, solving a quadratic quadratic equation, in chapter 4, being able to deal with linear inequalities, which we had in 9.1. To begin, let's look at this introductory example, and if you've been following the lessons, this is the same one that we had started with in lesson 9.2. So we already know a few pieces of information about this quadratic. We know the zeros. So we know that this is at x equals 3, or x is equal to -1. We know that the vertex is at 1, -4. So we already have all that information. We had done it before. So it's going to help us when we're drawing. From chapter 9 or section 9.1, if this had been a line, the less than or equal to told us we had a solid line. Now that I have a quadratic, that less than or equal to is still going to tell me that it is a solid line for that curve. I'm going to call it a line, but we're really working with the curve. So let's graph this and see what that would look like. I'm going to use my graphing software to do this. So this would be our parabola. Notice I've used that solid line because it's an or equal to. And just like with our line, our linear inequalities, when we're dealing with the lines, it is less than or equal to. So if I think about the fact that I have my y-intercepts at -3, I need a number less than -3, let's say -6. This has to be in my solution. Or we can think about it as numbers less than that curve. So we have to shade. So we have the points on the boundary line are already denoted because there's a solid line. And now we have all the points less than that parabola. And so we're shading. Our answer in this particular case is the graph. This is different than in section 9.2. In 9.2, there was only one variable, just the x, so it was a number line. Here, our answer has to be a graph. So we have another question that's being asked. And this question is asking us, is the origin a solution to the inequality? Why or why not? Well, is the origin a solution? Let's find out where that origin is. Origin is at this point, 0, 0. Is that a solution? No. According to the graph, we know it's not a solution because it's not in the shaded region. Right? So if I have the graph, I can answer it that way. What if I didn't have the graph? So what if I didn't have the graph and all I had was this statement? Oh, I'll shade it in there. Let's say I just had that statement. How am I going to tell if it is a solution? Do I have to graph it? No, I can use this statement. And remember, the origin is the point 0, 0, where x is 0, y is 0. If it is a solution, then this statement right here would be true. Well, let's test it. Y is 0, x is 0. When x is 0, I get -3. So the question we're asking is 0 less than or equal to -3? Is that true? No. So this is false. No, that's not true. Therefore, the point 0, 0 is not in the solution region, or is just even simply not a solution. So we can answer the question algebraically and we can answer it graphically. Let's try another example. This example has quadratic and vertex form, so that's going to make that fairly easy for us for graphing. We already know our vertex. I have a graphing checklist, and that's just the key things that we need to be able to do when we're graphing. So let's just look at the graphing checklist to start with. We want to have our vertex plotted, if possible. If the vertex isn't an integer, at least that we have it designated so we know where it is, or we have a table of values to cover that. But that's a key point. Should have at least 2 other points plotted. So we're looking for a minimum of 3 points. Should be on either side of the axis of symmetry. If they're not, get those points so you can have more than those 3. Should use the entire graph. And technically with these curves you need to have arrows on the end. Our graphing software often doesn't do that, but remember that the curve continues. And lastly, we should draw our boundary line accordingly. So we need to make sure, is it a solid or is it a slotted line? And then we're going to shade. So those are 4 things that we need to be aware of when we are graphing. Okay, so we're asked to graph this and we have a vertex. Our vertex is 3, -1. Sorry, 3, +1. My bad. Okay, so we have a vertex here. We know it opens up. Okay, and from here we can do our table of values. Now some of you are more familiar with using transformations than others, so you can go ahead and do that. If you don't know how to do that, we should just do a little table of values. And when I do my table of values, I always start with my vertex and I kind of put it right in the center because I am going to build on either side of the vertex, and that's going to work for my axis of symmetry. So because I'm dividing by 2, I want to have an even number. I'm going to use some odd numbers. So let's just try 1. And I put 1 in for x. 1 subtract 3 is -2. -2 squared is 4. 4 divided by 2 is 2. 2 plus 1 is 3. Now, understanding axis of symmetry, I know that there's another point, 5, 3. Now let's try a -1. So -1 subtract 3 is -4. -4 squared is 16. 16 divided by 2 is 8. 8 add 1 is 9. Knowing my axis, using my axis of symmetry, there's a point at 7, 9. That's really key when we're doing table of values. Using that axis of symmetry. What it's also doing for me is it's giving me a number of points. So I'm going to have a very good drawing for my parabola. So we have the vertex, we have numerous points. I'm going to extend that parabola up, and I made one mistake. I did not draw my boundary line accordingly. So let's just back that up. Instead, draw like that. Okay, that's better. Why? Because it does not have the or equal to. Now we're going to have to shade, and it says greater than this parabola. So I need to have points that are inside the parabola, in here, which is above my curve. And my answer would look like this. Why don't you try this one? There are multiple ways to find the graph to get to your table of values. I am going to show you a couple of ways. So I want you to try it on your own and see what you do first. So when I'm looking at this, I really want to get to a point where I can do a table of values and I can plot this. But I need one key point, and that's my vertex. There are multiple ways to find our vertex. I can just do trial and error and get to it. That's not my preferred method. We can use the formula for PQ, and if I do that, my value of P is negative B over 2A. So that's going to give me 2 over negative 2, which is negative 1. Okay, so that's telling me that my P is negative 1. And if I put negative 1 into my function, so this is my function right here, and if I put negative 1 into this function, I'm kind of going into my, getting a little crowded there. Let's look at what it gives me, and then we'll just decrease this. So this gives me a negative 1 plus a 2 plus a 3, 4. So that's telling me my vertex is negative 1, 4. So that is using the concept of the P and the Q. Okay, so this is coming, these two things are combined together. Okay, so that's using the PQ. I'm going to erase that. And I'm going to show you how you would do that if you're completing the square, because some of you, that's your preferred method. I want to make sure that we're smooth with it. So when I'm completing the square, I'm going to be factoring out the negative 1 from my x squared and from my x, like so. I'm going to be continuing on. I'm going to complete the square, x squared plus 2x plus 1 minus a 1. This is the perfect square, so we'll factor that. So that's x plus 1 squared, negative 1 plus 3. We're going to have to distribute the negative. So that is negative x plus 1 squared, now plus 1 plus 3, negative x plus 1 squared plus 4. And we can tell, again, our vertex is negative 1, 4. So there's two ways to do that. One of the things that the vertex form does do makes it maybe a little bit easier to do some of the values in your head when you're doing your table of values. That's all up to you. Either way, because of the leading sign, we know that this parabola is going to be opening down. Let's just find some points. So here on our parabola, what are some points so we can graph this? So we have 0. If I put a 0 in, I have 3. So that tells me then at negative 2, it's a 3. And if I put a 1 in, I'm going to get a 0. And if I put a negative 3 in, I also get a 0. So let's plot that. And we need to look at the sign. So we need to know, am I having a solid or a slotted line? As it has the or equal to, it's going to be solid. So negative 1, 4, 0, 3, 1, 0. Okay, and we just extend that graph like so. We're shading less than. So if I'm shading less than, I have to shade below this graph. And so that's what the answer is going to look like. Okay, this is our last example. It's kind of the flip. In this case, I actually have the graph shown. I know where it's shaded. and I need to come up with what equation fits this. So this takes us back to chapter 3, where we had to write the equation of a parabola, right? Given the vertex and a point. Well, we've got this information. This point is 1, 1. Maybe not the best one to use because of those coordinates, so it might be a little confusing, but just keep in mind that there's my x, there's my y. Okay, my vertex is negative 2, 4, and so this would be the P and this would be the Q. My equation for a parabola, y is equal to a x minus p squared plus q, that's vertex form. Putting in the values for y is 1, x is 1, p is negative 2, but it is subtract a negative 2, okay, because the subtraction is part of that formula, plus 4. And we're going to solve for a. So I'm subtracting 4 from both sides. We have negative 3 is equal to a, and this is 1 plus 2 squared, just to make sure you have the sign correct. And so that gives me a, and this is 3 squared. So this is negative 3 is equal to 9a. Divide both sides by 9, and I get negative 1 over 3 is equal to a. Oops. So I actually have the equation for this inequality. So we have, make sure I have room, y, and I have negative 1/3 x. Remember, it's subtract a negative 2, so that's plus 2 squared plus 4. So there's what would I have for the equation. Now we look at the graph and the shading to tell the inequality. It is a solid line. You can see we have a solid line. So we have at least an or equal to in here. We're shading above the line, so these y values are greater. So we're saying that y is greater than or equal to negative 1/3 x plus 2 all squared plus 4. Here are some questions for you to try. You'll note that word problems 9 and 13, I thought they were a really good combination of section 3.1 and 9.3. So at this point in time, you can see that concepts are starting to bundle together and that I can't just learn this outcome without using other pieces of other outcomes.